are really very closely interwoven. That logic permits you to go from one up to the other. It may be unbelievable that I can demonstrate that equal times will be swept out if the forces are directed toward the sun. And just to, if I may try, I will show you one demonstration to show you that those two things really are equivalent. And so that you can appreciate that there's more to merely the statement of the two laws, that the two laws are connected such that reasoning alone will bring you from one to the other. And the mathematics is disorganized reasoning, and that it's good to know how to do that, so to appreciate the beauty of the relationship of the statement. So I'm going to prove, if I may, the relationship that if the forces are directed toward the sun, that the equal areas are swept out in equal time. So we start, here's the sun, and we imagine that at a certain time, let's say the planet is here, and is moving in such a way that, let's say 1 second later or 1 hour, pick any time, let's say 1 second later, it's moved in such a manner that it has gotten to the position 2. Now, if the sun did not exert any force on it, then by Galileo's principle, it would keep right on going in a straight line. So in the same interval of time, later, the next second, it'll move exactly the same distance in the same straight line to the position 3, were there no force. All right, now first we're going to show that if there's no force, equal areas are swept out in equal time. I remind you that the area of a triangle is half the base times the altitude, and that the altitude is the vertical distance to the base. And that if the triangle is sort of cockeyed, there's a name for it which I forget, obtuse, then the altitude is this vertical height here. See, I know about the triangles, I just don't know the name. Now let us draw the lines to these 2 points in the case that there was no motion whatsoever. The question, this doesn't draw very well, I'm not accurate, but these 2 distances are equal, remember. The question is, are these 2 areas equal? Well, consider the triangle made from the sun and the 2 points 1 and 2. It's this one. What's its area? It's this space multiplied by this height. And what about the other triangle, which is the triangle in motion from 2 to 3? It's this base times the same altitude. The 2 triangles have the same altitude and, as I indicated, the same base and have the same area. So far, so good. If there were no force from the sun, equal areas would be swept out in equal times. The 2 triangles have equal area. But there is a force from the sun. And during this interval, from 1 to 2 to 3, the sun is pulling and changing the motion in various directions, this way, that way. To get a good approximation to that, we'll take the central position or average position here and say that the whole effect during this interval was to change the motion by some amount in this direction toward the sun. That means that although the particles were moving this way and would have moved this way in the next second, because of the influence of the sun, the motion is altered by an amount that's poking in this direction. That's parallel to this, exactly parallel. These lines are parallel. It's the direction in which this new motion is. The new motion is a compound of what it wanted to do and the change that's been induced by the action of the sun. So it doesn't really end up at position 3, but rather at position 4. So now we would like to compare, it's getting complicated in the diagram, the triangle 2,4S and 2,3S. I'll show you that those are equal. Because they have the same base, those 2 triangles, this one here, and the one that happened when we had no force. The one with force and with no force have the same base. And do they have the same altitude? Sure, because they're included between parallel lines, and so they have the same altitude. And thus the area of the last triangle I drew is the same as the second one I drew, this 1, 2, 3, and that I had proved earlier was the same as the first one. So in the actual orbital motion of the planet, the area of the first, in second, and in the second are equal. So by reasoning, we can see a connection between the force, the fact that the force is toward the sun, and that the areas are equal. Not ingenious, no? This was, I borrowed this from Newton. It comes right out of the Principia, diagram and all. The letters are different, that's all, because he wrote in Latin. These are Arabic numerals. But incidentally, Newton made his proof geometrical like this, and made all his proofs in his book geometrical of this type. Today we don't use that kind of reasoning. We use a kind of analytic reasoning.